Hello, geometry. Today we're going to talk about geometric proofs. So a couple days ago we talked about algebraic proofs. Now we're going to move on to geometric proofs. So same kind of idea as algebraic proofs. With a geometric proof, you're going to have two columns. You're going to have a statement and a reason. As we go through these commonly used reasons and definitions, everything that's in black, these are going to be your reasons. So definition of a supplementary angle, that is, or definition of supplementary, that is a reason that you can give in a proof. Definition of bisect, that's a reason you can give in a proof. Things like that. Everything that I'm going to write down below, those are going to be your statements. So what you would say to get to your reason or to get to the end of the proof. Okay, so the first thing we're going to look at is definition of supplementary. That's going to be a reason. An example, angle ABC and angle CBD are supplementary. So since they're supplementary, I'm going to draw a straight angle with a ray not bisecting it, just cutting it in some way. So A, B, C, and CBD. Those are the angles we are talking about. So what we can say, because we know that they are supplementary, we can say that the measure of angle ABC plus the measure of angle CBD equals 180 degrees. We know that because they are supplementary. Supplementary angles add up to 180. The next one, we have definition of bisect. So as an example, ray BD bisects angle ABC. So again, I've got some kind of angle here, general ABC, and we know that this ray BD bisects the angle. Something that we know because the ray is going to be bisected, or the angle is going to be bisected there, we would know that the measure of angle ABD will be equal to the measure of angle DBC. Okay, next one, definition of a linear pair. As an example, we know that angle ABC and CBD are going to form a linear pair. I'm actually going to just copy this picture that I did up here because we can use that same one again. It's the same idea for a linear pair. So since we know that these two form a linear pair, what you can say is that the measure of angle ABC is going, or plus, sorry, the measure of angle CBD is going to equal 180 degrees, because we know that the angle measure of a linear pair is 180 degrees. Okay. The next thing we're going to talk about is substitution. If we know that AB equals BC, and we know that AB plus BC equals AC, substitution says we can sub in both of those, one or both of those pieces. So AB equals BC, so I'm going to change AB into BC. So BC plus BC equals AC. So that would give us that 2BC equals AC. Or very similarly, plug in BC for AB. So we would have, or sorry, plug in AB for BC. So we would have AB plus AB equals AC, which means that 2AB equals AC. All right. The transitive property, we have A plus B equals 180 and C plus D equals 180. What the transitive property means, if we've got two pieces that match, we can break that apart or really bring those together and say that A plus B equals C plus D. Okay. Addition and subtraction property of equality. If we have that AB plus BC equals BC plus CD, this would be the subtraction property because you would subtract that BC from both sides. And then we would know that AB is equal to CD. Okay, vertical angles, kind of back to our unit 1 just a little bit. If we know that angles 1 and 2 here are vertical angles, they are directly across from each other. So the reason would be vertical angles, but we can say that the measure of angle 1 equals the measure of angle 2. The next one, angle or segment addition postulate. Oh, well, there's an extra word there. Angle or segment addition postulate. There's this back part. You don't need that twice. It's the angle addition postulate or the segment addition postulate, 2 pieces. Okay. What this says as an angle, if we've got, let's just call it A, B, C, and then we've got C, B, D. We can say measure of angle A, B, C plus the measure of angle C, B, D is going to equal the whole angle measure of angle A, B, D. So if you remember back to unit 1, we had the part plus the part equals the whole. So that's an example for an angle. The segment looks very, very similar. Really, the only thing that's going to look different is your picture. Lost my train of thought there. So if we have 2 pieces of a segment, we'll call this A, B, C. You can take your part, so AB plus your second part, BC, and that's going to equal the whole length of AC. Okay, and the last thing we are looking at, if we know that angle ABC is congruent to angle CBD, we know that those measures are equal. The measure of angle ABC is equal to the measure of angle CBD. That's just the definition of congruent. Okay, so remember, everything in black those are your definitions, your reasons. Everything that I wrote down, those would be the statements that you would say on the left-hand side of the proof. Okay. So we are going to look at this example 1 first. We are given that angle 1 is congruent to angle 4. It's already drawn nice in our picture for us. So I'm going to start off my proof. You make a 2-column proof, statements and reason. Our first statement, your first statement is always going to be something that is given. So we know that angle 1 is congruent to angle 4. And your reason for that is given. Okay, the second thing that we can tell from our diagram here, we have a pair of vertical angles. We've got angle 1 is congruent to angle 2. That is by vertical angles. And we also know, because of vertical angles, that angle 3 is congruent to angle 4. Okay, once we have all that, we have that angle 1 is congruent to angle 2 and angle 3 is congruent to angle 4. But from that very first step, we knew that angle 1 was congruent to angle 4. So in our step 4 here, we can jump to angle 2 is congruent to angle 4. This is going to be by the transitive property. Because we've got those two pieces that are equal to each other. Once you get to your final statement, the thing that you were trying to prove, your proof is finished. All right. On the back side, you'll see a lot of these kind of fill in the blank proofs where you're given some of the pieces and you have to figure out what either the reason is or what your statement is that goes with that reason. Okay, so example 2, we are given that angle HKJ is a straight angle. This angle right here, we are given that that is a straight angle, and we know that IKI bisects the angle HKJ. Our final step of this proof will be that angle IKJ is a right angle. That is what we are trying to prove. All right, your first step is always going to be a given. This one we have 2 givens. So I'm going to take a peek down at my second step. The second step is to say that measure of angle HKJ is 180 degrees, which means that we need our first step to be the first given. Angle HKJ is a straight angle. Then as we go down through our proof, the measure of angle HKJ equals 180 degrees. The reason for that would be the definition of a straight angle. All right, moving down, we can see that our third step is another given. The given that we have left is that ray KJ bisects angle HKJ. Because of that, we know that IKJ is congruent to angle IKH. That's by the definition of an angle bisector. Since those two angles are congruent, we can add them, or not add them together, set their measures equal to each other. So the measure of angle IKJ is equal to the measure of angle IKH. And then the next step, step 6. Oh, that was by the definition of angle congruence. The next step is the angle addition postulate, which means we need to take the 2 parts and set it equal to, add it together, set it equal to your whole. So we know that the measure of angle IKJ plus the measure of angle IKH is equal to 180 degrees. That is by the angle addition postulate. And then the next step, we've got 2 times the measure of IKJ equals 180 degrees. This comes from between steps 5 and 6. We know that the measure of IKJ is equal to the measure of IKH. So we can substitute that back in to get 2 times the measure of IKJ. So I'm going to say, just for reference sake, this is steps 5 and 6 that comes from. And then divide both sides by your 2. So the measure of angle IKJ is 90 degrees, which is the division property of equality. The last step, what we were trying to prove all along, the angle IKJ is a right angle, and this is just going to be by the definition of a right angle, or of right angles. All right, we've got one more example to go through, so if you want to take a second and try to start this proof on your own, pause the video, and then resume it, and I'll talk through it. Okay, we're going to write a 2-column proof. Statements, and our reasons. So we know that the measure of angle LAN, the measure of angle LAN, LAN, sorry, the whole angle, not just a little piece, LAN is 30 degrees. That is our first given. Okay? Because we know that that measure is 30 degrees. Actually, I'm going to go ahead and do both the givens back to back. It doesn't really matter if you split it up or if you go back to back. So our second given is that the measure of angle 1 is equal to 15 degrees. This is a second given. So we know that this angle is 15 degrees. All right. Now, because we have two pieces and then the whole, we can say that the measure of angle 1 plus the measure of angle 2 equals the measure of angle LAN. So piece, part plus part equals whole. That is the angle addition postulate. Ooh, did not mean to scroll up there. Okay, once we know that, we do know the measure of angle 1 from right here. So we can substitute that in. So we know 15 degrees plus the measure of angle 2 equals the measure of angle LAN. And this would be by substitution. Oh, the pencil's going to die. Good thing we're almost done. Okay, once we know that, actually, I can knock out two birds with that one. I also know the measure of angle LAN, don't I? It is 30 degrees. That is from step 1. So I'm going to say substitution steps 1 and step 2. Both of those givens, I can use those values and substitute them in. And then we are just simplifying. We're kind of back to an algebraic proof. So the measure of angle 2 is going to equal 15 degrees. That is the subtraction property of equality. And then if we know that the measure of angle 2 is 15 degrees and the measure of angle 1 is 15 degrees, we can say that the measure of angle 1 equals the measure of angle 2. That is also by substitution. That is from steps 2 and 5. And then because we know that those two angles that add up to equal one angle are exactly the same, we can say that AM, ray AM, bisects angle LAN. And that is by the definition of an angle bisector. Okay, that is the end of your notes. You have an assignment on Canvas. It is a drag and drop assignment. If you've got any questions, please feel free to reach out. This is Mrs. Murdoch. You can email me or come down and see me in the PLP room if you've got questions. Mrs. Landemeyer is also going to be available to help. Just make sure if you need help, you are asking for it. Have a great day.